How are you getting I squared?
Okay, let's look at lesson
You don't have to FOIL.
P.6. Okay, lesson P.6 is complex numbers. As you guys were already discussing, as you started looking at the notes, we're talking about the i's. I representing the imaginary number in math. Now, when we talk about complex numbers, okay, remember the official complex numbers are of the form a plus bi. So anytime you talk about imaginary numbers, they're of that form a plus bi. And so also when we talk about complex numbers, a complex number is a number of the form a plus bi. Now, before we get into this, let's review. What is I in terms of what is its mathematical value?
Anything that's not real. I'm just kidding. I don't remember. I'm not gonna lie.
And what numbers are not real in math?
Negative? I don't know.
Negative is
Infinity.
real, but square roots of negatives. So I represents specifically the square root of -1.
That's right.
Okay.
Because then you can, because then you replace it. Yeah.
Okay. Now,
It's all coming back now.
the other important piece of information, in my brain at least, you need to recall that I is the square root of -1. What is the value of I squared?
-1? Is it just one?
-1. Because if you take I and square it, what happens when you square a square root?
You get rid of the square
The
root.
square and the square root cancel out, and you're just left with the -1.
Because that's when you multiply the number by -1. When it's
Yeah.
Yeah, that's what I was thinking of.
Okay, so today is just a brief review, a whole bunch of different ways we can use these. Okay, so let's start basic. Example 1 is adding and subtracting complex numbers. You got a little hint there in your directions. Okay, 7 minus 3i plus 4 plus 5i. How do I do this?
Just combine like terms.
Okay, combine like terms, right? So with that in mind, what do we have?
11 plus 2i.
7, do note that this is a plus sign, right? 7 plus 4 is 11. And then -3i plus 5i is going to be 2i. And what is 11 plus 2i?
The answer.
The answer.
She tried to get me. Couldn't though. Big brain.
Okay.
She tried to get me.
B, 2 minus I minus 8 plus 3i. What are your thoughts on this one?
Combine like terms.
Okay, combine like terms. What are we doing first?
2 minus 8.
Okay, so do note it is a minus sign. So you are doing 2 minus 8, which is
-6.
-6. Then what?
-I minus 3.
-I minus 3i?
Yes.
What is that?
-2. 4i. Oh, yeah, you're right. Yeah, -4.
Minus 4i? -1 minus 3, right?
Yeah.
Okay. And final answer of -6 minus 4i. So, only thing there, just make sure that that subtraction sign, you're distributing it essentially, right? I didn't write it out as that because I don't know that all of you would, but you can also you could have rewritten this in a distributed form as well. Okay, so 1 is adding and subtracting. 2, multiplying complex numbers. When you're multiplying complex numbers, you're multiplying a binomial times a binomial, which means we need to FOIL. Okay, so what's first?
First.
Which is?
2 times 5. 10.
2 times 5, which is 10. O is?
Outside.
Outside. 2 times -I?
Minus 2i.
Minus 2i. I?
Inside.
Inside. 3i times 5?
15i.
Plus 15i. L, last.
Minus 3i.
3i times minus I? Minus 3i squared. Now, I don't know if it'll always say it, but your job is always to leave your answer in complex form. What kind of cleanup can we do here?
Combine like terms.
Okay, what like terms do you see?
-2i and positive 15i.
Okay. Negative 2i plus 15i is
13i.
13i.
And then we set up above I squared is -1, so we can take -3 times -1.
Okay. So do remember, don't leave an I squared. I shouldn't ever see I squareds in your answers because I squareds is equal to the value. I squared is equal to -1. So a negative 3i squared is -3 times -1, which becomes
3.
positive 3.
Then combine more like terms after that.
Yeah. So that guy becomes positive 3. We have the 10 there out front. We already had that 13i. So the other piece of like terms, 10 and 3 is
13
13.
plus 13i.
What's 13 plus 13i?
39, eh?
The answer.
The answer. Okay. Review happening okay?
Yeah, so far.
Okay.
Next is a little.
Next gets a little crazy. Okay, example 3. Raising a complex number to a power. So the idea here, they're giving us z is this lovely value of 1/2 plus square root of 3 over 2i. And they're asking us to find z squared and z cubed. Okay? So, when we talk about finding z squared, that means we're doing 1/2 plus square root of 3 over 2 times I, quantity squared.
And then we get up the cube, right? Later.
Right, but hold on.
Later.
Let's square right now.
Yeah.
So what do I need to do here?
Either write it again in FOIL or square root it and get rid of it.
I'm trying to find z squared.
Del square.
So we can't square root it.
Attribute the square
FOIL it.
on the. I don't FOIL it.
Yeah, if you're gonna write it.
Yeah. Officially, we have to FOIL this. Okay? So we're doing 1/2 plus square root of 3 over 2i times 1/2 plus square root of 3 over 2i. Okay, it is a FOIL. If you just square the first term and square the last term, you're missing your insides. You're missing those outside and inside terms. So, let's multiply our fractions. 1/2 times 1/2, 1/4. Outsides, 1/2 times square root of 3 over 2i.
No clue.
It'll just be.
Just multiply fractions.
It should be square root of 3 over 4.
If you're multiplying the fraction, 1/2 times square root of 3 over 2, so 1 times square root of 3,
Aye.
square root of 3, 2 times 2 is 4, and it was a regular fraction times an I fraction, so an I.
That's simply.
Those were your outsides. What about insides?
Same thing.
Same thing.
Okay, it's square root of 3 over 2i times 1/2. Again, 1 times square root of 3 over 2 times 2 times I. So square root of 3 over 4i. And last, square root of 3 over 2i times square root of 3 over 2i.
Square root of 9 over 4i squared.
And what is square root of 9?
3.
3.
3. So I'm going to write square root of 3 over, square root of 3 times square root of 3 is 3. I'm going to go ahead and write that as 3. 2 times 2 is
4.
4. I times I is I squared. And it's not that you couldn't start with square root of 9 and write it in the next step, but that's one I automatically do, especially at pre-calc. Okay. We're looking for some cleanup here, yes?
Let's see.
What cleanup do you see?
I'm just gonna start with the easy one. Make 3/4 negative.
Okay, so 3/4 I squared. Since I squared is a -1, this is going to become minus 3/4. And that is right there because I squared again is -1. I'm going to wait till the next step, but here in a moment, We'll clean up the 1/4 and the -3/4, yes?
Yes.
Now, let's talk about these middle terms. Square root of 3 over 4i plus square root of 3 over 4i.
How about just 2 square root of 3 over 4i?
Attaboy.
Okay. That's exactly what I need to think. So I'm throwing those ones. They're not imaginary, the invisible ones. Is that better? Okay. To get you guys to realize, okay, the square root of 3 and i's make these like terms. They both have a square root of 3. They both have an I. What is the coefficient of the square root of 3i? Well, it's something over 4. It's a 1/4. So what's 1/4 plus 1/4? And that is 2/4. And so we're going to say plus, I want to write this, 2/4, but I'm going to write it as 2 square root of 3 over 4 times I. Now, there's two small pieces of cleanup that we can do to finish this off. One we already talked about. What is 1/4 minus 3/4? Yeah, 1/4 minus 3/4 is -2/4, but we know better, and we're going to reduce -2/4 to -1/2 plus 2 square root of 3 over 4 times I. What does that reduce to?
Oh, just 1/2 square root.
Yeah, the 2 over 4 can reduce to a 1/2. The 1, do we need to write the 1 on top with the square root of 3?
No.
No. So we can write this as square root of 3 over 4 times I. Sorry, I got a little bit down. So that is our z squared, if you will. Questions on that piece?
Neat.
Okay, that was z squared. We were also asked to find z cubed. What are your thoughts about z cubed?
You're going to do it 3 times,
Okay, 3 times?
which means you FOIL it once and then FOIL the answer. But since we already know the answer of one of the FOILs, we can just use that answer and then FOIL it by.
Okay. So here's the deal, z cubed. We can do parenthesis times parenthesis times parenthesis. But we already know what 2 of those parentheses together are. So my thought would be, think of this as we're going to do z squared times z. Is that a logical thing to do in this case? Now, if we didn't have to do z squared first, then you're just going to have to do them 2 at a time. Do 2, get that answer, and then do the other one. So, in this, z squared. Well, z squared right over here, yes? Z squared we came up with to be -1/2 plus square root of 3 over 4 times I. The original z was given as +1/2 plus square root of 3 over 4 times I. And we're ready to FOIL?
I thought the square root of 3 was just over 2 because we made it 1/2.
Oh.
I didn't realize that till now.
No, that's my mistake there. Okay, are you guys seeing the mistake he's pointing out? We said it out loud right. You hopefully wrote it right. I don't know. I wrote it wrong. Okay, so 2/4 back over here, reduced to 1/2. So this should be square root of 3 over 2. Yeah. The rest of that's right, yes? -1/2 plus square root of 3 over 2i. Now, what does that affect here? I copied it from over there, so that's what's getting me in trouble. And I'm at least glad it's being pointed out to me now, rather than after we multiply all this. Just saying. The original problem was over 2, wasn't it?
Yep.
Okay. Double whammy. Does this look better? Z squared, negative 1/2 plus square root of 3 over 2 times I. The original Z was given as 1/2 plus square root of 3 over 2 times I. Okay. Now I'm behind because some of you have already seen multiplying this out. So no denominators of 4 yet. Okay. Did you FOIL?
Almost done.
Yeah.
Negative 1/2 times negative 1/2.
Pause.
You said negative 1/2 times negative 1/2.
Right. 1 times 1 over 2 times 2. It's, negative times positive. Okay.
She's going crazy.
Having issues here.
I was like waiting for you to realize it.
Okay. Nope, I didn't even realize it. Negative 1/2 times positive 1/2. Can we agree that that's negative 1/4?
Yeah.
I would
Okay.
say yes.
Continue. Outsides. Negative 1/2 times positive square root of 3 over 2I. Negative times positive is going to make this a minus or negative. 1 times square root of 3. Square root of 3. 2 times 2 is 4 times I. That was your outsides. Insides. Square root of 3 over 2I times 1/2.
Same thing, just positive.
Okay, yeah, and this time it's a positive times a positive, so positive. Square root of 3 times 1 is square root of 3. 2 times 2 is 4, and that's an I. And then last, square root of 3 over 2I times square root of 3 over 2I.
3 over 4I squared.
Okay, square root of 3 times square root of 3 is 3. 2 times 2 is 4. I times I is I squared. Okay. So we still have the negative 1/4. What about these middle terms? Yeah, we didn't have multiplying conjugates here. So a negative square root of 3 over 4 times I plus the square root of 3 over 4 times I is going to cancel. What do we know about this 3/4 I squared?
The negative 3/4.
Yeah. Reminder, I squared is negative 1. So this does become minus 3/4. What is negative 1/4 minus 3/4?
Negative.
Right? Negative 4/4, which is negative 1. So we found z cubed to be negative 1. I'm not going to be too nitpicky about this. You know, if you were doing something online or whatever, I'm fine with negative 1. What is negative 1 in complex form? So what is negative 1 in a plus bi form?
Negative I squared.
Or yeah.
Don't go I squared, just think of it as negative 1 plus
0.
0i. In other words, there's no imaginary part. Okay? Again, negative 1, your basic answer, but
Right, 8 plus 0 equals 8 as an answer.
it is what it is. It's complex form. Okay.
You said we don't care if we write it's negative 1.
I should, unless there's something really specific in homework, I'm probably okay with it. Okay, we're ready for example 4? That was multiplying complex numbers. Now we've got to divide complex numbers. Now, as you look at this, 2 divided by 3 minus I. Can I do 2 divided by 3 minus I?
No.
Not easily. So, when we had something that involved square roots in the denominator. Remember, we could never leave square roots in the denominator. Well, same idea, we can't leave i's in the denominator, because an I is a square root. So, do you remember something called the conjugate?
Yeah, it's the opposite of the denominator.
Yeah. You're multiplying by the conjugate of the denominator. Conjugate is keeping your first and last terms the same, but just changing that middle sign. Okay? So, with that in mind, 2 minus 3i, what is it I'm going to multiply by? The conjugate of 3 minus I is 3 plus I. What I do to the denominator, I do to the numerator. Okay? So, let's do some math. You'll like this better than what we just did because if nothing else, there's no fractions. Okay, on top, what is 2 times 3 plus I?
6 plus 2.
Okay, you guys with us there? 6 plus 2i, because you're just distributing. Denominator, what am I doing in the denominator? Foiling? First, 3 times 3 is 9. Outsides, 3 times I is plus 3i. Insides, negative I times 3 minus 3i minus I times I minus I squared. From here, it's a bunch of cleanup. 6 plus 2i for right now is just 6 plus 2i. What do you know about that denominator?
The 3 i's cancel out, and then the negative I squared would be negative 1.
Okay. 3 i's cancel out. That is the whole point of conjugates, folks. If your middle terms don't cancel out, you're doing something wrong. That's the whole point of conjugates. And then minus I squared is going to be minus negative 1, which is indeed plus 1. And 9 plus 1 is 10.
So you would make that 3 plus 2i over 5. No.
Partially right. We are going to clean this up. We are going to clean this up a little bit. When you see 6 plus 2i all over 10, what do all of those terms divide by?
2.
They all divide by 2, yes? 6, 2i, and 10 all divide by 2. So reduce everybody by 2. 6 divided by 2 is 3. 2i divided by 2 is I. And 10 divided by 2 is 5. Now, while you could write it like this, if we are going for that official a plus bi form, split this into 2 terms. Right now we have one big fraction. How do we write this as 2 fractions added together?
3/5 plus I.
Okay. 3/5 plus, and then I over 5.
Yep.
That works. The other option would be to say 1/5 I. So again, just proper form. Okay, what's the difference on B?
You have total on top and bottom.
Yeah. It's just your top is a binomial also, just means spoiling top and bottom. What are we multiplying this fraction by to rationalize it? What are we multiplying by?
2 plus 3i.
Okay, conjugate of the bottom, which is 2 plus 3i. What we do to the denominator, we're doing to the numerator. Okay, on top, have you guys spoiled this out?
No.
Yeah.
What's first?
10.
10. Outsides,
15i.
plus 15i. Insides,
2i.
plus 2i. And last,
3i squared.
3i squared. Denominator, first, 4. Outsides,
6i.
plus 6i. Insides,
Minus 6i.
minus 6i. And last,
Minus 9i squared.
minus 9i squared. If you are realizing there's going to be some canceling, could you skip writing those middle terms?
No.
I was going to say yes. Okay. Okay, what do we see happening here? In the numerator. What do you see?
Combine the i's and then change I squared to -1.
Okay. So 3i squared, since I squared is -1, that plus 3i squared is really just going to become -3. So on top, when we clean that up, 10 minus 3 plus 15i plus 2i. So I'm seeing that as 7 plus 17i. What about that denominator?
Cancel out the i's and then multiply -5 by -1.
So negative minus 9i squared becomes plus 9, if you will. So my denominator becomes 13.
13.
Okay. If I'm going to express this as two fractions, how am I going to write this? I'm just going to show you another way you could write it here. 7/13 plus 17/13 I. That I can be in two different locations. Doesn't matter to me. It could be on top of the fraction like I demonstrated in the last one. It could be beside the fraction like I demonstrated here. The one place it cannot be is it cannot just be in the denominator. That's a no-go. Okay? Okay, guys. Two more real quick.
Real quick.
Yeah, real quick. Okay. Example 5.
Quadratic.
This looks like a problem you would have seen in the previous homework.
There's no i's.
Okay. So we're solving the quadratic equation, x squared plus x plus 1 equals 0. If you were to try to factor this, it's not going to factor. I can't get a product of 1 and a sum of 1. That's impossible. So when you can't factor, your backup plan is the quadratic formula. Of course, quadratic formula, make sure your equation is equal to 0. What's my ABCs?
1, 1, 1.
Okay. A is 1, B is 1, C is 1. So, here we go. Negative B, -1, plus or minus the square root of B squared, so 1 squared, minus 4 times A times C, all over 2A. Okay, some cleanup. -1 plus or minus. What's going on under that radical?
Equal -2.
Yeah, 1 squared is 1. 4 times 1 times 1 is 4. 1 minus 4 is -3. All over 2. Now, guess what? We don't get to leave our answer like this. Why can't I leave my answer like this?
Because negative square.
There's a negative square root. How do I deal with that negative under the square root?
You make it square root of 3 times square root of -1.
Okay. So I'm going to do my side note over here. Square root of -3 is square root of -3. Square root of 3 times square root of -1, correct?
Year.
What is the square root of -1?
I.
I. So this is square root of 3 times I. Now, what I will tell you, normal form, is when you have square root of 3 times I is to put the I out front and say I square root of 3, and that's just for cleanup's sake. You don't want the I to accidentally get under the square root and I have the square root of I. That would just be weird. So -1 plus or minus I times the square root of 3 all over 2. if I'm splitting this into two fractions for a complex form, as two fractions, this is going to read -1/2 plus or minus.
That's I squared is
Oh,
gonna
I
have.
just did square root of 3 over 2 and then put the yeah.
Yeah, and there you could put I square root of 3 over 2 as well. Both are good. Okay? They're both correct. There's nothing wrong with either of them. Just be careful about putting it directly after the square root, which we didn't do there. Okay. Example 6. This is the easy stuff. All the hard stuff was in the middle. Plotting complex numbers. Okay, the complex plane is just like the coordinate plane. Normally we have an x-axis and a y-axis. Well, now instead we have an a-axis and a b-axis. Or in other words, we have a real axis and an imaginary axis. So notice right here, a number in the form a plus bi has the equivalent ordered pair of a comma b. So it asks us to plot u, v, and u plus v in the complex plane. So if u is 1 plus 3i, what is that as an ordered pair?
It is 1, 3i.
Or just 1 comma 3? Because all we need are the a and the b values. So 1 plus 3i, 1 is the real part. It's kind of like your x. 3 is your imaginary coefficient. It's the y. Excuse me. So in order to plot u, how do I graph 1, 3? Right 1 and up 3. That is point u. Excuse me. What about v? It's 2 minus I. How is that as an ordered pair? Okay. You got the real part 2. Minus I means we have a coefficient of -1. So v is 2 -1. So we're going to go right 2 and down 1. And that is v. And then the other thing we're asked to do is we're asked to plot u plus v. How do I plot u plus v?
Add 1 plus 3i plus 2 minus.
1 plus 3i plus 2 minus I.
3 plus 2i.
1 plus 2 is 3. 3i minus I is 2i. And so what is this as an ordered pair?
3, 2.
The ordered pair, 3, comma 2. So in order to plot u plus v, it's 3, comma 2. So right 3 and up 2. And that is u plus v. Okay. Homework. Starts on page 51. 2 through 16 evens. 26, 28, 34, 36, and 38 basically. It's 34 through 38 evens. 42 and 44. All evens. Have it done for tomorrow, please.
8.